Hello, and welcome to Network Wednesday here on Answer Everywhere. Today we're looking at the source code for tcpdump, which is a popular utility for, well, dumping TCP packets. Um, I should say before I start that I don't know a ton about networking. I don't know a lot about TCP. The premise of this show is that we jump into a source code repository that I'm unfamiliar with and poke around and see what we can find. So that's what we're going to do with tcpdump. Before we get there, I wanted to add some administrative stuff that I want to mention. One is that the my channel's been growing much faster than I expected, and I wanted to thank everyone and let you know how much I really and truly appreciate all the love that you've been sending. The comments warm my heart, and it's nice to know that people are also interested in this thing that I'm doing that I thought was maybe of interest to only a small niche of people. But I was going to make I think a joke earlier this week that I had reached 256 subscribers, and that we would next, I would next say something when I reached 512 or whatever. But I slipped, and I'm already up to like 568. So things keep growing very quickly, and I'm trying to scale up the professionalism to make sure that I'm producing things that are I'm doing right by the people who are tuning in. So I wanted to say I really appreciate it, and thanks for all the everyone who's been excited about it and everyone who's given me feedback and all that stuff. And I mean that truly, sincerely. Last week on Network Wednesday, I did, it was the first Network Wednesday, and I looked at the TCP source code. And this video got way more views than any of my other videos. That was a surprise to me. So this got 5.6 thousand views. And then my next video down has nearly 500. So I suspect where a lot of those views came from are all of the, on the internet, there are a ton of people who are interested in things like networking and potentially also like things like penetration testing, like kind of maybe the offensive side of security. So if you found my video through those sorts of things, I just want to make sure that I orient you and set expectations that I'm not a security pen tester person. I'm not the right person to learn about TCP from if you're looking to master it. So what we're going to do today is we're going to look at the source code and hopefully breathe a little bit of life into it, make it seem like it's more something that you can poke around in, the source code of tcpdump, that is. But I probably won't understand the subtleties of everything that's going on from a networking perspective. There are lots of great places to learn about those subtleties. So I wanted to just mention a couple of them. A comment on the TCP source code video, which, by the way, you should check out if you're interested in TCP, suggested the series of books by Douglas Kummer, I guess you pronounce it, and David Stevens. They have this classic series of books called Internetworking with TCP/IP. It looks like they have it on the Internet Archive, which is where I pulled this up. So you should be able to, borrow this or read it or whatever online. And a lot of these older books, especially older editions, you can often get for like $5. Sometimes you can find them for free. I have kind of books, similar books, mostly about like the Linux kernel or about the Unix environment in general. I don't have this particular series, but I have seen it around. I might have flipped through it a few times. But all of this old stuff that kind of goes back to the 70s, 80s, 90s is super well documented. So there's a wealth of stuff out there. And typically, if you study computer science at university, then you would have some sort of networking class where you talked about protocols. I think that's that people do. My background was in math before I became a developer. So a lot of the core classes that you would take coming up in the computer science university curriculum aren't in my background. And so what you're seeing me do in this video is learning about TCP dump and not like explaining TCP dump from any area of expertise or anything like that. I wanted to also point out that there are lots of just websites that have useful examples. This is one that just came up when I did some sort of web search, and this seems to be more from the hacker or offensive exploration perspective. So they've got what they call I thought somewhere they called it maybe tactical. Yeah, okay. Here up in the title, they call it 22 tactical commands for TCP dump, and you can do different things like capture based on the protocol, based on IP address, write a capture file, combine filters, those sorts of things. And I figured just for fun, let's also ask ChatGPT what it knows about TCP dump. So I'll ask it to explain some basic uses of TCP dump. The program TCP dump. And just to see what it can do, I'll ask it to respond like a black hat conference presenter. Let's see what it does. Maybe it's not going to respond. We'll put this aside and see if it's going to respond. Maybe on the left here. Here we go. You know. And then on the right, I have the TCP dump GitHub page open. I will put the link for this page in the show notes, I guess it's called. All right, so ChatGPT is saying, TCP dump, the ultimate tool for network sniffing and packet analysis. As a black hat conference presenter, I can tell you that TCP dump is an essential program for any hacker worth their salt. First off, let's talk about what TCP dump is. Simply put, TCP dump is a command line packet analyzer that allows you to capture and inspect network traffic in real time. Cool. With TCP dump, you can capture packets on a specific network interface or capture packets that match specific criteria, such as source or destination IP address, port number, or protocol. And then it's going to tell me about basic uses, and it's going to give me some commands. So here's how to capture, I guess, for the host. And then down here is going to be how to capture traffic on port 80. And so the command is, it looks straightforward. So we're going to call TCP dump as root using the sudo. And we're going to say host, and this is presumably the host that it's going to match. Error in body stream. All right, well, and here's the example of TCP dump is much more powerful than just capturing traffic. You can also use TCP dump to filter and analyze packets in real time. For example, if you want to capture any TCP packets that have a SYN flag set, you could run the following command. We're going to call it TCP dump, and we've got this string, where I guess this string is going to be some sort of like predicate or program. And I don't know what the syntax is, but I guess TCP is the protocol. TCP flags is maybe like we're indexing among TCP things. We want things that have flags. And TCP-SYN is not equal to 0. So the SYN, what's it called? The SYN flag is set. Okay. Or if you want to capture all packages that contain a specific string in the payload, you can run the following command. And we're going to TCP dump, we're going to call it with the flag A. Don't know what that is. And then we're going to pass it this string. And the string is like a description of a logical operation. It says TCP contains, and then the string in double quotes password. As you can see, TCP dump is a versatile and powerful tool that is essential for any network analyst or hacker with its ability to capture, filter, and analyze packets in real time. And then ChatGPT breaks. All right, cool. So yeah, that's what's going on with TCP dump. So let's look at the code. And maybe to add on to what I was saying before, when I was talking about this channel versus some other channel that might be a good place to learn how to use tcpdump. I wanted to say that when I was hanging out on Twitch more, so I originally started streaming on Twitch, and a lot of the streams that I saw seemed to be, a lot of the streams that I saw from the software programming world seemed to be people who were doing kind of like security stuff. So if you hang around there, I think maybe more at nighttime, at least on my in the US, then that seems to be a thing that happens. There are, of course, no doubt a ton of videos on tcpdump. Some will show you how to use basic commands, and you might be able to also find like live streams of people kind of using them to study actual network streams. So there's a ton of stuff out there. I want to make sure that those people who are creating that content get some love in case you're looking for that sort of stuff and stumbling on my video. And what I'm looking for here is I would eventually like to learn about how networking stuff works, how stuff like TCP works and UDP. But I'm kind of deliberately going at it in a meandering way. So we looked at some web browsers, and we didn't look at, I don't think, at any of the networking code, but we looked at gRPC, and we looked at some of the more networking adjacent stuff there. And we've looked at the Linux kernel and of course last week the TCP code. And so over time, especially on Network Wednesday, we're going to be looking at software that uses networking or that implements networking. And something like TCP is going to call, so something like tcpdump is going to call the TCP code, presumably in a somewhat interesting way. And then other code, like maybe server frameworks, might have some TCP calls that are maybe a little bit more prosaic. And just over time, over the series of a bunch of videos, I think we're going to get a sense of what's going on. And that's totally different from like how you would learn things in a university environment. And those are both good. If at Google when I'm working for an employer and I want to understand something, I don't just read the source code. I read also tons and tons of documentation. And so sometimes that documentation is just like a series of markdown files, and sometimes it's books and whatnot. So all of those things are important. I don't want to give the impression that like you can always just go to the code and that you shouldn't be doing other things. It just happens to be that for this show, what we're doing is looking at code and not so much looking at documentation. So that's, I just wanted to put that out there. So here's the tcpdump source code. I assume this is the real source code. It's got the tcpdump group. Sometimes sometimes GitHub is just a mirror, especially for something as old, I think, as tcpdump. Actually, let's find out how old it is. (1988). Right, so that's pretty old. When did TCP come out? So this is going to take us back to the DARPA days. Yeah, I think we looked at I pulled up the original TCP standard from the 80s, I think. I think it was part of a DARPA project. I think I did that maybe on the TCP video. But yeah, so I think 80s, late 70s maybe is when TCP officially came out. And so 88 is when tcpdump comes out. Okay, so here's the code. We have a bunch of kind of metadata type files, including a README, which is good. Adder to string, we've got some files that look like, there's a bunch of real files in the root directory, which in most source code repositories we've looked at so far is not the case. But that's the case here, so we'll have to look pretty carefully at the root directory. But before I do that, let me see what other directories we have. Okay, not much. We've got modules, which I'm going to assume I can skip. We've got doc, missing, and tests. I suppose I'm going to look at tests. Actually, let's take a quick look at tests before we do anything else. So we've got these pcap files. I think that these are probably capture files. Maybe these are like golden files for comparing tests to. And in fact, almost everything seems to be a pcap file or an out file. Do we have any .c files? Sorry, we had to truncate this directory to 1,000 files. We're emitting nearly 350 files. So if there are C files, that they might be omitted, but I'm going to guess that this is just what's in this directory. So I saw something about radius. Let's see if we can pull up the radius file just for fun. A bunch of RFC stuff. So let's just look at this just to see what's in here. And I think GitHub is not going to want me to look at this, but all right. I'm going to try Emacs. Somewhere here. If I go to here and what I'm in testing. Okay, so no .c files, but let's pull up radius.pcap. Okay, so it's some binary file. I don't know if there's a pcap mode. Okay, cool. So it's a binary file. And then we had this like test list or something, crypto tests. That sounds cool. Non-BSD tests, test list. Let's look at test list. All right, what is this? So print X. These are like triples, no, quadruples. We've got print-x, print flags.pcap, and print x.out, and -x. These are various flags applied to a TCP session. So I guess something's going to read these files and do tests. So this seems to be like some sort of command or whatever, or like flags for configuring tcpdump. And this is maybe an input file or like a source for the test. And then this is the output. And maybe we're going to compare. I don't know, just a guess. Let's look at test run. Okay, so test run is a Perl script. Interesting. Okay, so what was the tests list, right? Yeah, so we're going to run simple tests. We're going to open test lists. And look at, this is, I guess something that begins with a comment. Something that's an empty line, maybe. I don't know what unlinked core is going to do. But I think, yeah, okay. So we're going to call split, which presumably is going to split the line into variables. So we're going to get a name, an input, and output, which is what we expected. And then options is the last line. That was things that like just -x. And then we're going to join the options with the empty string, I guess, to make it a list of, not the empty string, but the string that consists of a single space. So this is going to be a space separated list. We're going to hash somehow, maybe like a hash table. And then we're going to call run one complete test on the hash. So this is doing the thing that we suspected it was doing. It's basically just reading these files kind of like as a set of commands, and then running and using Perl to run those commands. Okay, so that's what's going on in tests. So with that out of the way, let's take a look at the C files. I'm going to guess that these are straight C and not C++. Let's see if GitHub will tell us what the breakdown of the code is. Yeah, C, 93.6% C, and 0.7% Perl. I think this is probably the first time we've come across Perl in the wild on this channel. All right. So there's a ton of stuff here. And it's not really organized in a hierarchical way. So we're going to just scroll through and look for anything that looks like a main entry point or that otherwise looks especially interesting. I guess I'll look at RPC message. tcp.h, we should look at tcpdump.c and udp.h, sure. Print who is, a bunch of print stuff. NFS, that might be interesting, but I also don't know anything really about NFS. OSPF in OpenFlow. Look at OpenFlow. I guess I'll look at OSPF and NFS. Net dissect. That could be interesting. I don't know if net dissect is a protocol. We'll look at nameser, which I'm guessing is a name server thing. IP6 and IP. I'm guessing these are IPv4 and IPv6. Here's the IP protocol. Yeah, we'll look at that. Some VPN stuff, L2. I don't know if that means like a layer 2 VPN. Func adders, get servant, cpack, config, configure, compiler tests, checksum, chdlc. We'll look at that just because that could be interesting. We'll look at ATM. I don't know what AF and AH are. Some stuff that looks like utilities like address to string, address to name. Okay, so this should be enough to at least get us started figuring out what's going on in the source code. And the top comment on RPC message says Sun RPC is a product of Sun Microsystems. It is provided for unrestricted use. Okay, so this is going to be, I guess, Sun's RPC system. Copyright 1984. I think that so. This is an older RPC system. I'm not sure if it directly inspired anything in the Google RPC system, gRPC or Stubby or protocol buffers. But it's certainly an antecedent. It's certainly somebody in the people who are super up on top of their RPC systems will probably have known it at Google. Okay, so I'm going to look at tcp.h first. We get some, copyright and boilerplate and all that stuff. Okay, so TCP header per RFC 793, September 1981. So I think that is the first TCP RFC. I vaguely recall it being kind of around the right number. And this seems like it's around the right year. So this is just a struct for the TCP header. We've got sport, which is short for source port, destination point, destination port, sequence number, acknowledgement number, data offset, I guess reserved, the window, the checksum, and urgent pointer, whether it's urgent. We've got this define, which is going to do a computation, get u1 of th, then tf off x2. We're going to AND it with ox f0, and then shift over 4. Don't know what that does, but some sort of computation that I guess must be common if you're writing TCP dump. We've got some TCP flags like fin, sin, rest, might be rest, push, ack, urgent, eck, no echo, ECN echo, okay, and CWND reduced. Some TCP option stuff. These are all just defining constants so that the source code is more readable. OpenFlow port, RSTP port, just different port, beep port. Is there a beep protocol? I must know. So let's grab this port. I have too many tabs. Computer to say display error. So it seems to be some. Is this about motherboard beep codes? Like, I'm wondering if this is like a way of beeping over the internet. Beep, the definitive guide. All right, O'Reilly has a book about beep. Maybe it's not related to motherboard beeping. I don't know, but we need to find out. Okay, this is some. That's where beep comes in. It's a toolkit you can use for building application protocols. It works well in a wide range of application domains, many of which weren't of interest when HTTP was being designed. Beep's goal is simple. All right. I assume it's some sort of acronym. Let's see if Wikipedia knows about it. Okay, Block's Extensible Exchange Protocol is a framework for creating network application protocols. Beep includes building blocks like framing, pipelining, multiplexing, reporting, and authentication for connection and message-oriented peer-to-peer protocols with support for asynchronous full duplex communication. So I guess you can use it to build protocols from 1998 by a guy who worked on POP3 SMTP and SNAP, SNMP. I don't know how to pronounce. I'm sure there's a way that people pronounce that protocol. I always just called it SNMP. Okay. All right. So it's a protocol designy thing. All right. So that's what was in the TCP, I think, header file. Mainly just defining constants, things we're going to use over and over again. So you can import it, and you have all those constants defined in your file. So here's a tcpdump.c. And just out of curiosity, how big is it? Pretty big. Oh, really big. So about 3,300 lines. So I'm wondering if maybe I should just jump straight to Emacs. I'm going to lose my way, I think, with 3,300 lines. So maybe we see if we can find this. Oh, it's just tcpdump like .c, right? Okay. What is going on? I think I may have activated some sort of zoom mechanism on XFCE. How do I leave this? Somewhere? System? Accessories? Settings? Probably accessibility. What have I done? Maybe it's the VM manager that's zooming in. Let's try this again. Oh, Lord. If I just, yeah, what's going on here? I definitely think it's I sized XFCE too large. Hmm. You know what? Sorry to do this, but I'm just going to reboot. I don't know a faster way to solve this issue. I can just Google. Oh, did I just click that? No. Maybe Zoom site. I'll do it. I'll try a web search. What's going on? XFCE. Whoa, now. It's like a magnifying glass, right? XFCE entered zoom mode. How do I leave? Yeah, okay. Alt plus scroll wheel? What? You have to be kidding me. Yeah, that's not great user user experience. All right, sorry about that. Let's pull TCP dump back up. I think I can find it like this. Okay, so that's opening in the browser, and then let's oopsie, open it back up in Emacs. All right. Does it have? No, I don't have that installed. Okay, so TCP dump, and I was looking at TCP dump. Let's see. Okay, all right. So we've got a bunch of if defs, and we've got a comment: TCP dump traffic on the network, on a network, written in 1987 by Van Jacobson at the Lawrence Berkeley Laboratory. Okay, interesting. Mercilessly hacked and occasionally improved since then via the combined efforts of Van, Steve McCann, and Craig Lares of LBL. I guess LBL being Lawrence Berkeley Laboratory. Okay, so we're going to check whether we have a config, in which case we can include config.h. Here's some pcap stuff. Some older versions of Mac OS X ship pcap.h from libpcap with a libpcap based on 0.8. So libpcap is related, I think, to TCP dump. In fact, if we look at the TCP dump homepage, it's got libpcap. And let's find out what pcap is. PCAP is an application programming interface for capturing network traffic. While the name is an abbreviation of packet capture, it is not the API's proper name. Unix-like systems implement PCAP in the libpcap library. Okay, so and then the website for PCAP is TCP dump. So this is this seems to be including, so this PCAP stuff is TCP dump adjacent, presumably written by similar people, or at least likely written at the same time, possibly also at the Lawrence Berkeley Laboratory. So it seems like TCP dump is going to use PCAP, I guess, for the lower level parts of capturing, and then maybe it's just going to, TCP dump's area of expertise will be looking at captured dumps or whatever and analyzing them. So we're checking if we have lint stuff. We've got crypto stuff. I don't know what capsicum is, but I feel like I've heard the name. All right, so we found PCAP open in the capture library. So we'll be using the remote capture APIs to find PCAP remote before we include pcap.h. So we get those APIs declared and the types and defines that they use to find. All right. So if we have remote support, we're going to include some PCAP stuff and also some standard stuff. Path name separators are different on Windows versus like Unix. There's a capabilities convenience library. All right. So if a code depends on have libcap ng, it depends also on have cap ngh. If have cap ngh is not defined, undefine have libcap ng. All right. Some free BSD stuff. We're going to include net dissect and interface and address to name and mock dep. Don't know if mock is related to the, there's a couple of things mock could be. I'm not sure what it is. ASCII. So some string processing stuff, some interface stuff, which might be network interface. Print FB type. Pathmax. We've seen pathmax in lots of places, I guess. Pathmax was a big concern in the 80s. Maybe it's not so important anymore. All right. And if we have pcap create, then we've got a flag for the buffer size, some stuff about dump files and rotating them. This is exported because in some versions of libpcap, if libpcap is built with optimizer debugging code, which is not the default configuration, the library imports variable name, blah, blah, blah. Okay, so some stuff about some various flags: D flag, G flag, L flag, and print filter code rotate dump files, number of files created with the G flag rotation the last time the dump file was rotated, and some other stuff. All right. Yeah, can we get to, let's scroll past a lot of the define stuff. Or is it all defines all the way down? Let's see. I mean, eventually it looks like we're getting to functions. We have make file name. I wonder if I can fold. Do I have the stuff to fold this so that I just see the functions? Hungry delete. I can do forward statement and backward statement, right? What's the should be like forward defun. Does that work here? Oh, well. Let's see. Okay, so we're down here. And I'm seeing if defs and that sort of stuff all the way through. So this is, I guess, this is like conditional stuff in the sense that the preprocessor is going to run, and depending on various things you have defined, you're going to get different code. So that makes it a little bit hard to reason about what the code is doing. But overall, it looks like we can find recognizable functions like compress save file, and we can have a sense of what it's going to do. Here's static void dump packet and trunk. So this seems like it might be useful. So let's see what we pass in. We're going to give it a user. I'm not sure exactly what ucar is, but it seems to be like essentially like a character array that's going to be used as a string. You're going to give it a const. You can give it a const pointer to pcap pkth dir. I'm going to guess h dir is header, and this is going to be packet header. So this is going to be the pcap packet header, I assume, and you're going to give it a const pointer to sp, which is another ucar. I don't know what sp is going to be. Maybe source packet. All right, and so what are we going to do? We're going to declare a dump info struct. Increment the number of packets captured, which is not passed in, so is, I guess, is maybe like a global variable that it's keeping track of. You're going to increment info delay, which I don't know what it does, but we can find it. And then dump info is, we're going to take the user and I guess cast it as a dump info thing. Okay. So XXX, I don't know if that means like poison. This won't force the file to rotate on the specified time boundary, but it will rotate on the first packet received after the specified G flag number of seconds. Okay, so you can, I guess, ask it to rotate at some interval, and it won't do it necessarily at the specified time boundary. I guess it's not looking at the clock, but I guess when we get our first packet, we're going to check the flag, and that's going to kick off a possible rotation. So if G flag is non-zero, we'll check if it's time to rotate by getting the time. Okay, yeah. So the time is greater than the specified window rotate. Okay, so this is kicked off, I guess, only after you call dump packet and trunk. So you have a packet, at least a packet header. And if we have capsicum, we'll do some file stuff. Okay, so this is rotatey stuff. All right, so again, we have this triple X thing. This won't prevent capture files. Maybe triple X means like warning, like, pay attention. This won't prevent capture files from getting larger than C flag. Okay, this only handles the C flag value, blah, blah, blah. All right. So if C flag is not 0, I'm not sure what C flag is. But we're going to call pcap dump ftel64 dump info to PDD. Let's read this again. This won't prevent capture files from getting larger than C flag, The last packet written to the file could put it over C flag. All right. And pcap dump ftell. Don't know what ftell is. Maybe we'll see if we can find some of these. These are presumably from the pcap library, so they may not be defined here. We can close the current file, that sort of thing. Okay, pcap dump. So as expected, eventually we're going to call pcap to dump. Can I do a series on NeoVim? Sure, do a series on NeoVim. I don't. Yeah, sure, that sounds good. I'm not a Vim user. I've used it sporadically. I think NeoVim is a Vim implementation, right? But yeah, I'd be happy to. That sounds great. Okay, so we're going to call out to pcap dump, and we're going to pass it sp. And sp was something we passed in here, and I feel like we haven't otherwise told it what to write to. So I feel like we're going to write to sp. But I thought elsewhere sp was source packet. So I don't know why we would write to a source packet. It doesn't seem quite right. So that's possibly what's going on. It's also possibly not what's going on. Okay, here's a nice function that seems like it's relatively self-contained. Dump packet. It's going to take a ucar user pointer thingy, a pcap packet header, and a ucar sp again. And as before, we're going to create dump info, increment package captured, increment info delay, and somehow manipulate this user into a dump info. And then we're going to call pcap dump on the dump info right arrow pdd. Maybe one of the D's is dump, giving it H and SP. And if def have pcap dump flush, and if we have the U flag set, then we're going to call dump flush. So we're going to flush the pcap stuff. And then if pcap info NDO is not null, we're going to print the packet. All right. And then we're going to decrement info delay, which we incremented here. And then if info print, we're going to call info of 0. And in fact, in the previous function, we decrement info delay too. So it seems like whatever info delay is doing, we increment it before doing some kind of work with the packets, and then we decrement it when we're done with that work. So it's a little bit like it has the flavor maybe of like a critical section thing. I'll look for info delay in a little bit. I just want to get maybe a couple of more functions just to get oriented here, because I feel like I don't yet have a sense of really how they've designed it and what they're doing. We've got this thing, this request info. It's going to take a signo _u_, and it's just going to look at info delay and increment info print if info delay is, I guess, non-zero or non-null or whatever. Otherwise, it's going to call info of 0. And flush pcap print packets captured, which is a void function with a void return value. And we're going to set the variables previous packets captured and first to 1. And then we're going to check whether info delay is 0. And if either first or packets captured is not previous packets captured, in which case we're going to fprintf standard error got some string, and that string is going to be populated with packets captured. And then we're going to use a carriage return, I think. And then we're going to set first to 0, and we're going to set previous packets captured to packets captured. Okay. So we set it here to 1, and we declared it here, right? And yet we're setting it to packets captured. So are we just shadowing this here? And like, is this supposed to be have an effect outside of this function? Because we don't loop. Yeah, I don't know. It's a static. Okay. All right. Okay. So this is a function that's called once each second in verbose mode while dumping to a file. So this is a static void callback, verbose stats dump. So in verbose mode, we're going to call this function. And we've got some stuff about timers firing. P void, I'm not sure what that is. Okay. Some more stuff about verbose package dumped. Some stuff about deprecation, whether we have libcrypto. If we do have libcrypto, we're going to print some SSL, I guess, or I don't know if it knows about TLS. Maybe it still calls everything SSL. Let's search for the capital TLS. Yeah, okay. So what is any of that stuff doing? I don't know. What was it? Info dump? Info delay? Okay, we've got these two static ints, info delay and info print. Maybe we can just use it. Look at all occurrences of info delay. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 occurrences. One declares it. And then we have a bunch of occurrences where we're incrementing it and then decrementing it, incrementing and decrementing, decrementing, and we can check it. Huh. Let's see if we can find other occurrences of info delay in the code base. And they all seem to be in tcpdump.c. Let me make sure that yeah, that's a different buffer, right? Okay. So everything's here. Let's see if the internet will tell us about info delay. Possible race condition. Yeah, I don't know. See if ChatGPT knows. Oh, I have to log in again. I don't feel like doing that. All right, so whatever info delay is, it's kind of keeping track of when we're dumping packets. I don't know. Let's look at if info delay. Okay, let's look at the stuff that actually conditionally does stuff on info delay. So if you requested info, then we're going to check info delay, and that's going to tell us whether we're in like one of these critical section stuff. And if we are, we're going to increment info print. And if we're not in info delay, so we're not in a critical section, nothing is in a critical section, because we're essentially like counting the number of things that are in critical sections, then we're going to call info of 0. And I'm guessing info of 0 is going to print stuff. So, and then, so info delay is like, I guess, asking, should I delay printing? Because I guess I am limited on resources. And if so, I'm going to increment info print, and then maybe info print is going to, something is presumably going to read info print. And if it's 0, I guess maybe it's going to print. So let's see if, find info print uses. Okay, so here's info print. We declare it. We set it to 0 here. It's going to set it to 0. Older versions of libpcap didn't set PS if drop on some platforms. Initialize it to 0. So if, okay, what is this function doing? This is pcap stats info. Okay, so this is info. Great. I was going to look at info anyway. So the info function, okay, and the 0 that we saw, it was making a call to info of 0. 0 is verbosity. So, okay, so 0 means presumably minimally verbose. And we're going to, info is going to declare a pcap stat statistics struct. and set this thing, set this stats thing, and we're going to check if pcap stats of PD and stats is less than 0. I don't know what it means to be for stats to be less than 0. Then I'm going to print an error, pcap stats, and we're going to get the error. Okay. Then we're going to set info print to 0 and return. And maybe this just tells something to print right away. Okay. And at the end of this info function, we're going to set info print to 0. Or maybe info print is how much stuff we have to print. All right. So we have that, and that. What else do we got? So this function, what is this function? This is one of those dump packet functions. And it's going to say if info print info of 0. So if we have stuff to print, is what this is saying, I guess. Print this. So, all right. And request info is if we're in info delay, it's just going to increment info print. And okay, I think I have a sense of what's going on. My sense is that oh yeah, before I make an error, let me look at print packet. This is different from dump packet, right? So it's going to also increment packets captured. It's also going to increment info delay, just like dump packets. But we're not going to call pcap dump, I guess. We're just going to call pretty print packet if we're in count mode. Sorry, if we're not in count mode. And at any rate, so info delay, the info delay section is just to do this count mode stuff. So if we're not in count mode, it basically doesn't matter. We can pretend it's deleted, in which case we're going to increment packets captured and check if info print, in which case we're going to call it info of 0. Okay, so I think that what's happening is it's an optimization to not have to lock stuff and ensure that like printing, if you ask something to print, the actual printing is really being triggered, it looks like, by the functions that capture packets. And one of the things that a packet capturing function might do as a side effect at the end of the function is to print stuff. And it only prints stuff if you've requested stuff to be printed, and whether or not you've requested stuff to be printed is recorded in info print. If I show some diagram while explaining, that would be useful if I had showed a diagram while explaining. Unfortunately, I don't have a diagram. I can try to I can see if there's like some TCP dump. Unfortunately, I don't know what I'm doing. So I typically don't have a diagram to explain. This is like the TCP protocol. Yeah, I'm not sure. Maybe I shouldn't have packet flow in there. Let's just try TCP dump diagram. I don't know. Let me try this. I'm going to move this over here. Okay, so I re-authenticated to ChatGPT. I'm just gonna see if it will answer any of my questions, because a lot of this stuff it's gonna be hard to find in a normal search engine. because most people don't look at the code of tcpdump. There will be a bunch of stuff about TCP, about how to use tcpdump, but in terms of how it's organized, actually maybe there's, let's see if they have like some really good documentation as well. So documentation, let's learn tcpdump. The most useful is, this is like the man page, right? README installation notes, change log, cheat sheet, advanced filters. So a lot of this stuff I don't think is going to mention anything like info delay at all. So in terms of understanding the code, ChatGPT might be the best thing right now. It's a function defined in tcpdump. Info print is a function defined in the tcpdump codebase that's used to print out additional information about a captured packet. The function is called in various places throughout the code where packet information needs to be displayed, such as when a packet is being analyzed or when statistics are being gathered. The info print function takes several arguments, including a pointer to the packet data. Is there an info print function? It's a static int. Is it describing the info function? Static void info. What's the fastest way to find this info function? Let's just try occur of info. Yeah, there you go. Okay. So the info just takes verbosity. The info print function takes several arguments, including a pointer to the packet data, the length of the packet, and a pointer to the struct pcap header, packet header. When called, info print formats the packet data and additional information into a human readable format and sends it to the standard output. The output includes details such as the source and destination MAC address, IP addresses, port numbers, protocol type, and other packet information that can be useful. So isn't info print a static int? That's what it is, right? You got to say, ChatGPT. I apologize for the confusion in my previous response. Huh. InfoPrint is defined as a static integer variable in the tcpdump codebase and not a function. I don't know where did you go wrong, ChatGPT? Here we go. The purpose of the InfoPrint variable is to control the amount of packet information that is printed to the console during packet capture. It's used to filter the output and prevent the console from being flooded with excessive packet information. Okay, so that's basically what I said. It's an optimization. When it's set to a value of 1 or higher, tcpdump prints out a summary of each packet, including the timestamp, source, and destination addresses. Protocol type and packet length, when it's set to 0, tcpdump only prints out a one-line summary for each packet, which includes a timestamp, source, and destination address. Is that true? Let's look at the tcpdump code. Where was I? In Emacs? Let's look at dump, what is it, packet maybe? And trunk. Here's dump packet. It's the more advanced version. Here's the less advanced version. So if info print is 0, then we're doing nothing, right? But you're telling me, ChatGPT, that if it's 0, it prints out a one-line summary for each packet. Maybe there's somewhere that it calls info dump info. Oh wait, am I looking at the wrong thing? Info print. Yeah. Okay. So I think ChatGPT is mistaken again, but it's more or less in the right direction if you're willing to forgive it being a little bit sloppy about stuff. Okay, so this is tcpdump. Let's actually find where some of the callback stuff is used. All right, verbose stats dump, I guess, has a callback, pcap handler callback. dump packet in trunk is assigned to the callback variable here. Okay. So this, whatever this function is doing, is this dump and truncate? Where does this function begin? I think maybe I can jump to the backward statement. No, that's just going to jump one statement. I think it's maybe worth reminding myself how to do backward defun and Emacs. I don't know. I used to know, but for whatever reason I've forgotten. Okay, so let's just see if we can figure out where this thing is. Can I just call it defun? Match. All right, whatever. Maybe I can look for a curly brace. This is main. Okay, so let's look at main. Main seems gigantic. All right, so you take the normal stuff, argc, and the variable arguments. We're going to declare a bunch of stuff, including count, op, which is maybe operation, I, which presumably some sort of counter, bpf uint 32, local net is 0, net mask is 0. So I guess in 32, bpf, these, and local net and net mask, these seem like IPv4 IP addresses. A bunch of character arrays, essentially. Don't know what CP would be. Maybe P is port, maybe like copy. Input file, presumably command buffer device, a device, our file name, v file name. Maybe read, write, and I don't know. These could be anything. I'm not sure. NP, maybe end pointer or something. And I don't know. A pcap handler callback. I'm not sure what DLT stuff is, and some dump info. Okay. So we've declared a bunch of stuff, and we're going to begin operating on stuff. Initialize the net dissect code. So I guess there's some net dissect library that's used for additional functionality. On platforms where the CPU doesn't support unaligned loads, force unaligned accesses to abort with the SIG bus rather than being fixed up slowly by the OS kernel. Okay. We're going to check whether we want to abort on misalignment, whether we have pcap create. Okay. And we've got a bunch of we've got a switch here. What are we switching on? Switch on op. Okay. So op, I guess, is an operation, like a pcap operation. Are these maybe, I guess, oh, maybe, probably options. Okay. So these are options. I think this is like command line flag parsing. And maybe we can check that by pulling up the man page for tcpdump and just seeing if some of these things are flagged. So B, let's look for capital B, or maybe dash B. B is buffer size. Okay. And capital A is print each packet. And yeah. All right. So if we see A, we are going to increment NDO and I guess set the, we're going to increment the A flag. Increment the B flag if we see B. And we're going to break. I guess we're going to break because we're handling one op at a time, and we're calling it this switch statement in a while loop that's getting the options one by one. Okay. So that's option parsing. We're going to switch on end P. And what is this? So if end P equals opt arg, case C. Let's look at what C does. Do I still have the man page open? I think it's capital C. C is file size. Do I know anything about NP? No. Okay. All right. So there's some stuff about endp, whether it's the, I guess, null character. There's nothing after the file size, so the size is in units of 1 megabyte. In which case we set the C flag mult to whatever this number is, 1 million. Otherwise, there's something after the file size. If it's a single letter, then if the letter is K. Okay, so this is like, I guess, like human readable file size information. Okay. And this seems to be just more flag parsing. Here is, are we done flag parsing? Hash. Is there a hash argument? Case option version, option tstamp. Okay. More, I guess, like configuring the behavior of the main function. And then we're going to switch on NDO T flag. I guess that's time. Based on the case, I'm guessing it's time. T is time. So case 0 is default. Case 1 is no timestamp. Case 2 is Unix time val style, or like microseconds or date, etc. Okay. Here we have W file name. If we're printing dissected packets to the standard output, and either the standard output is a terminal or we're doing line buffering, set the capture timeout to 0.1 seconds, a tenth of a second, rather than 1 second, as the user's probably expecting to see packets pop up immediately shortly after they arrive. All right. So if we're writing to a file that somebody's not like staring at, then maybe we can write slower. But if we're writing to a terminal or standard output, then we're going to set the capture timeout, which somehow is going to make us print faster. Presumably we're going to print at around, on average, a tenth of a second. But we saw that timing in tcpdump isn't necessarily by the clock time. What tcpdump is going to do is when it has a packet, it's going to see if it needs to print it. It seems like that's my understanding at this point anyway. We're going to check whether we're running as root. So with user, if run as root, prepare for dropping root privileges. Okay, if get UID is 0 and get EUID is 0, we're going to run with -z root to restore old behavior. If the username is not set, we're going to set username to with user. Maybe with user is set somehow by the command line so you can impersonate another user. Okay. There's this R file name stuff. If R file name is non-null, it's the path name of a save file to read. Okay, so that is read file name. If V file name is not null, it's the path of a file containing a list of path names, one per line, of save files to read. So I guess V is for save. And so we've got read file and save file. All right, if ndef win32, we don't need it. We don't need network access. So relinquish any set UID or set GID privileges if we have any. We do not want to set UID privileges when opening a trace file, as that might let the user read other people's trace files, especially if we're set UID root. Huh. Oh, if not def, if we're not in Win32, I guess is what it's saying. So we're probably in something Unixy, is maybe the inference. If set GID and set, we're going to get the GID and check if it's 0, I guess. Or no. We're going to get the GID and then try to set it and see whether that was successful or if it failed, maybe. And I guess we're going to try the same thing with the UID. And if they're non-zero, we're going to say that warning that this failed, that we couldn't set UID or GID. We do not want set UID privileges when opening a trace file. Okay. If we don't want them, then why are we warning them when they failed? I'm not sure, but I mean, this is good to see. I'm glad that tcpdump is like checking whether we have too many privileges. That's nice to see. I'm not sure particularly what that I understand why this why we're trying this and emitting a warning if it's something we don't want, but um, maybe if we spend more time hanging around the code or reading the docs, then it would make more sense. Um, some stuff about whether we've got timestamp precision, whether we have capsicum enabled. Then we're going to check the D flag and not device. Okay. This comment says we're dumping the compiled code without an explicit device specification. If a device is specified, we definitely want to open it to use the DLT of that device. Either default to DLT EN10MB with a warning or use the user specified value if supplied. I'm guessing device is a networking device. Whatever 10 MB is, something presumably about 10 megabytes. DLT, I don't know. Let's see if this is common. So DLT, maybe device networking. Distributed ledger technology. I don't think so, not in TCP. Let's try searching for this string. Thanks, Kyle. I'm glad that you love my videos. I really appreciate it. All right, it's a link layer, maybe link layer header stuff. So here we are on the here we're in the docs. This is okay. So this is useful. So the header type value. Okay, so this means all right. So this is Ethernet. Makes sense. Ethernet 10 megabytes. Okay. The DLT name is historical. So DLT probably doesn't really stand for anything anymore, but this means Ethernet 10 megabyte. Shouldn't we also get other EN things? Ethernet 3 megabytes. Do we get like in the gigabyte range? Encapsulated the OpenBSD. What is it? 10 gigabytes? I don't know. All right, so 10 megabyte Ethernet, I guess. So some stuff about printing Ethernet stuff. If device is null, that means we're doing a live capture. Okay. If device is non-null, then we're not doing a live capture. And so what are we capturing from? Let's see if the so we specify device type. Let's see. So these are like maybe like a Linux device. So maybe null is just interpreted to mean capture from whatever the default Ethernet device is. Well, let's find what it does. Yeah, okay. So pcap, okay. Find the list of interfaces and pick the first interface. So find all devices. And we're going to take the first one. So I guess if we don't have any devices, then we have an error. If device list is null, or I guess if we can't find devices, maybe there's like a permission issue, then we're error. If we do get a device list, but it's null, then we can't capture anything. Okay? This makes sense. Otherwise, we're going to string dump the dev list name into device. And that's, I guess, the first one because we have a pointer. And the pointer points to the first thing and we're just like calling name on it, I guess. And then we're going to free all devices on the device list. I guess tell the operating system that we're done with whatever, however we enumerated the devices up here. Okay. In fact, just out of curiosity, this is a pcap thing, so I don't think we're going to find this function definition. But I'm going to see if I can find this function. So let's see if we can just find this on the, okay, here's the man page. Yeah, the man page is good enough, I guess. So find all devs, constructs a list of network devices that can be opened with pcap create. That's great, but I'm really kind of curious about what it's actually called. Well, view in plain text, we return to main contents. Let's try searching GitHub for libpcap. Yep, the tcpdump group. And let's see if we can find all devices. I'm guessing it's maybe going to be in like pcap H or pcap C. This is a pcap file, perf.c. Find all devs test. That's nice. Some testing stuff, open test, capture test. Here, pcap.h. pcap deprecated. Maybe say pcap.h. Val grind test. pcap C, here we go. I thought I looked here. Did I not look there? Okay. So pcap find all devices is going to get a list of all capture sources that are up and what we can open. Returns -1 on error, 0 otherwise. All right, so we're going to declare some stuff. Find all the local network interfaces on which we can capture. Okay, so we're going to call out the pcap platform find devs, which I guess is going to do the platform specific stuff. And we're going to populate a what? A list. And ask each non-local network interface capture source types what interfaces they have. Okay, for all of the source types, we're going to call find devs op on them. Okay. So I was just curious. So probably libpcap seems a lot closer to the hardware than tcpdump, which is not surprising. So at some point, maybe in a future Network Wednesday, I'll take a look at libpcap, maybe, just because I'm curious to see code that is also closer to the hardware. All right, so we're back in main, the main tcpdump function. We've got some more set GID, get GID stuff. Let the user own process after captured device has been opened. Checking flags. We're going to try to use set data link via the pcap library. Okay. If pcap set filter, do some error stuff. Okay, so I'm beginning to get a sense of what's going on. A lot of this stuff is. I don't think these days you would have like such a. Well, I guess you would try not to have such a gigantic main function. A lot of what it's doing is reading the command line options, figuring out what routine in libpcap to call, and calling the appropriate routine. And then it seems like it's keeping track of the various packets, statistics about them, deciding when to dump information and whatnot. That seems to be what's going on in main. Let's see what else. Okay, so that's info we looked at. Compress save file is probably not so interesting. We print packet. I think we saw flush pcap. It's just going to call pcap dump flush. You can print packet captured. And again, we look at info delay and something about first and packets captured. And we use that to decide whether to print. All right, I'm feeling pretty good about tcpdump.c. Let's see some of the other files, which I think I closed. And wait, I have a ton of workspaces. Let's see if I can move. Can I move this between workspaces on XFCE? And how many Emacs do I have? I don't think I need 4 workspaces. Move down to 1. And let's close one of the Emacs and then go back to GitHub. Okay. So I had opened a bunch of files and then I accidentally made XFCE enter this magnifying glass mode, which is really easy to accidentally turn on and kind of hard to figure out how to turn off if you don't know what you're doing. So let's go back and maybe see what else we have here. So I'll look at, I guess I don't really care about RPC auth, but I'll look at RPC message. We looked at tcp.h, and that was a bunch of like defining constants. We'll look at udp.h, and I expect it to be similarly defining a bunch of constants. And a bunch of print stuff. I think I had opened NFS. Let's look at NTP maybe, and OpenFlow, and OSPF, and namesir, and netdissect. And I'm just looking at the headers. I have a sense of how they implement stuff. Whether that sense is entirely correct or not is a separate issue. But I think the value of looking in all of the C files is maybe doesn't justify making this one extra long. Okay, so here's UDP, and we are going to define a bunch of stuff. Is there anything else we do? No. Okay. This is mostly ports. I guess ports used for by different UDP protocols. And we've got the UDP header as a struct. 768, 1981. 768, 1981. Was 769 TCP? Are these consecutive RFCs? I keep forgetting that I can't just do that on GitHub. All right, so where's tcp.h? That was 768, right? I could have kept it open, but now I will keep it in my working memory. 768, and then what do we have here? 793. So they're not consecutive, but I think they are both in 1981. I think they are both in September. Okay, that's cool. I think I actually can call it to come back up. No? All right, whatever. So they're around the same time, but not consecutive RFCs. That would have been cool, but I don't know how you would have done that. All right, here we are in NFS, and we get a bunch of constants. So port, prog. In theory, maybe nowadays you would have this stuff be like a JSON file. You're just going to read it at startup. I guess there is probably efficiency to be gained by making them defines. So probably maybe you wouldn't do it in JSON, but it's basically data rather than code, really. So a bunch of stuff, ports, like maybe like flags, I guess you would call them. Read, lookup, modify, procedure numbers, write, cache, write, create, remove, rename. And we have some structs for common parts of the RPCs. Note, these structures are not always overlaid directly on the packet data. Sometimes we declare a local variable of that type and fill it up with fields extracted using byte pointers. So we don't use ND types for their members. Okay, and the structs have things like time, like seconds and nanoseconds. NFS version 3 special file number. So we've got special file stuff. File attributes and settable attributes. Okay, so FA type, FA mode, nlink, UID. Some ugly defines. I don't know what makes these ugly. We're accessing union components. Okay, I guess they're ugly because these are ugly to access. And so I think the defines themselves are less, I think maybe what it's trying to get at is the defines are less ugly than using this stuff directly, but who knows? Okay. Some more mode stuff. Okay. So yeah, basically data-y stuff for working with TCP. There's not a lot of, not TCP. For working with NFS, the network file system, not really any logic in there. That's kind of what I expected after looking at the TCP header and the UDP header. Here's NTP, presumably the network time protocol. structure definitions for NTP fixed point values. And we've got whatever this is. So 0, 1, 2, and 3. But it seems like they have 10 components. Okay. And there's an integer part and a fraction part. All right. So it's a UN32 in part fraction. Oh, wait. Yeah. Okay. UN16 in part and fraction part. Okay. And then NTP time. So this is just, again, essentially data. OpenFlow, I'm expecting the same thing. So there's no real logic. OSPF, same stuff. But I guess like how to... So I guess tcpdump doesn't really need to know the structure of something like NFS or OSPF or whatever. It's just going to look at packets and know about like their structs and stuff. But I'm wondering if somewhere there should be link state advertisement. This is potentially interesting. What is this? It's a struct again. I'm wondering if there's any logic that understands the protocols, or maybe that's all in libpcap. Or maybe it's nowhere. Maybe it doesn't need to understand anything. It just needs to know the structures. Name sir, I was guessing is DNS. So define constants based on RFC 883. Yeah, CD name, dname. This looks like DNS. Domain names. Was it not called DNS? Domain name service? Huh. What is it? 883 is the RFC? 882 and 883. Okay. So it is DNS. Maybe it didn't have that abbreviation back then. All right, net dissect. I have no idea what net dissect is, but we get some type defs. Data types corresponding to multi-byte integral values within data structures. These are defined as arrays of octets so that they're not aligned with their natural boundaries, and so that you must use the extract macros to extract them, which you should be doing anyway, so as not to assume a particular byte order or alignment in your code. All right. This is something for IPv4 addresses and net masks. It's defined as an array of octets. Okay, so we're defining type defing stuff. We're defining stuff. We're including some stuff. I wonder if we have real logic here. Do we have libsmi support? What is SMI? I think I'm confusing it with maybe MSI. All right. So whatever this thing, okay. So there's a struct. Do we have any functions? Net dissect options. Something on AIX. Is source or destination port. Maximum snapshot length. Is not negative. Extern void. So, okay, so we've got a bunch of external, I guess, functions. Net dissect options. So let's look at what net dissect is. Network dissection, MIT. Is this what I want? No, I don't think so. Whoa now, MIT. CCL, you're going to break the back button on me? All right. Let's try Wikipedia. Nothing. All right, let's try tcpdump and net dissect. And let's ask it to include our search terms. I guess let's try Google since everything seems to be having trouble. And I'm not really finding anything. There's still a ChatGPT open. I think I closed it again. Oh, well. All right. I guess we'll never know what net dissect is unless I'm still logged in at ChatGPT. Okay. Let's see if it knows what net dissect is. While it's working on that, let's see if we can close some more files out. All right, here's ip.h. This is presumably IPv4 support. We're going to include net dissect IP. And these are just definitions from the Internet Protocol version 4. And the top level comment is telling me it's definitions. So since I've seen so many definitions files, I'm going to believe them. And it seems to be true. I'm going to guess this is also just definitions. Definition of the Internet Protocol version 6. Okay. Interface.h. Yeah, there's not much here. We're going to include pcap.h. And something about BPF dump. And whether we have support for various things. But there's not much here. And I'm just kind of curious what CHDLC is. It's almost child. CHD, maybe DLC. Well, this is probably header length, unicast, bcast, type slarp, type CDP. Slarp seems like it's Googleable. Slarp. Cisco, HDLC. Hey, look at that. An encapsulation protocol for information transfer. It's bit-oriented synchronous data link layer protocol that specifies a data encapsulation method on synchronous serial links using frame characters and checksums. So we have to know what SLARP is. The Serial Link Address Resolution Protocol, SLARP. I'm guessing someone had fun naming that. Okay. Let's see what ChatGPT says. Yes, I am familiar with NetDissect. It's a tool for interpreting and understanding the behavior of deep neural networks. All right, that might be what I saw at MIT. Okay, so what is NetDissect in the context of tcpdump? So this CHDLC seems to be some Cisco protocol thing. ATM is this like the autonomous system stuff? This is like a classic networking thing. Asynchronous transfer mode. Since we're learning about networking, let's look at this. This is a telecommunications standard defined by the American National Standards Institute and ITU-T for digital transmission of multiple types of traffic. It was designed to meet the needs of broadband integrated services digital network. It's defined in the 1980s. In the OSI reference model, data link layer 2, the basic transfer units are called frames. In ATM, these frames are a fixed length 53 octets. So I guess it's a like a layer 2 protocol. I wonder if this will give me a list of layer 2 protocols. Protocol examples, ATM, ArcNet, Cisco. Okay. I apologize for the confusion. In the context of TCPdump, we're back at ChatGPT now, and it says NetDissect is not a tool or concept I'm familiar with. TCPdump, yeah, okay. So to summarize, NetDissect and TCPdump are two separate tools used in different contexts. That's forgivable. I don't think I can really expect ChatGPT to know everything about every source code repository that exists. So here's something, all right, bpf dump.c, we have a C file. So it might be more than just headers or more than just definitions. We've got a bpf dump function. It's going to take a bpf program, which might be the same as a filter. So we should be including something BPF related, right? So we're including netDissect and interface.h. I don't know where we get the BPF struct from. I don't think there was a header file, but maybe there was. Let's see. No. Okay. So SN maybe instruction. We're going to BPF length. And where's P? So the program, we're going to get the instructions and set it to instruction. And I guess the S at the end of instructions maybe tells me that this is a like a pointer to a vector of instructions or whatever, an array of instructions. We'll check the options. And we're really just going to like print stuff. We're going to print the instruction code. And that's all we're doing. Printf. Or we might put the BPF image as a string. Don't know what a BPF image is, but this is going to print BPF stuff. And that seems to be all it does. And RPC message is, I'm going to guess, definitions again, because it's a header file, and it's the Sun RPC protocol from the 80s, I think. Okay, Sun RPC rejected reply body, Sun RPC call body. Yeah, just out of curiosity, let's see what a call request looks like. So it's got a CB, I don't know what the CB prefix is, but RPC vers, probably version. CB prog, I guess program. Verse, maybe version again. Proc, maybe procedure. And then a Sun RPC opaque auth, so some sort of opaque credentials. That's the body. And it's a bunch of ints and then credentials. That's the call body. Where's the stuff that like a message? So here's the definition of the message struct. It's got a transmission ID, I guess, XID, a direction. I don't know what that means. Maybe send or receive or something like that. And a union of a call body or a reply body. And here's the call body definition. And then we've got call and reply. These are just, I guess, like to access the parts of the struct that we're dealing with. Yeah, okay. Sun accepts stat, success, unavailable, mismatch, unavailable, args, error. Reject stat, mismatch, or error. And I guess message type is call or reply. I still don't know where we put the actual message. So if we're making a call body, who knows? We've got a thing in a direction and some sort of body, but there doesn't seem to be like a text. Like how do you know what function I'm calling? Okay, so that's TCPdump. How long have I been going on? About an hour and 40 minutes. I'm tempted to take a look at libpcap, but we're already really long, and I wouldn't want to rush through it since it seems pretty interesting. So we'll do that at a future time. I do have a sense of what I'm up to next week. I'll post that before I go live on tomorrow. But libpcap isn't on there, and it's not on there for the next few weeks that I've got kind of sketched out. So if we look at that, when we look at that, that'll be kind of in the future. But that's tcpdump. So I guess I'll try at the end of these videos to give like a recap of what I think that we learned. One thing is that, as I said, I think like midway through the video or so, tcpdump isn't calling, doesn't seem to be calling like current Linux system calls or Windows system calls directly. That's presumably part of pcap. So pcap is doing things like enumerating, by pcap I mean libpcap, is doing things like enumerating like your networking devices and deciding which one to look at. And it's doing things like actually capturing the packets. And then tcpdump is kind of like a Swiss Army knife for dealing with libpcap and deciding which info to print, which info to look for, like to filtering out stuff. And so that's why it's closer to the user face, whereas libpcap is closer to the machine interface. And so that's how they broke up the complexity of this particular task. And yeah, so we learned that. The structure of tcpdump is really understandable. So tcpdump.c, it's hard to follow any like one function, but it's if you kind of like squint your eyes and ignore the if defs, then you get a sense of what it's doing. It's not really doing a whole lot. It seems like it's doing command line parsing. It's dumping packets by calling pcap, and it's got some optimizations to tell it to print in a way that's not going to interfere with the performance of your machine. It's not going to like overload the print buffer, and it's not going to slow down your network traffic too much. So those are all good things, and that seems to be what it's what it's designed for. And then a lot of the rest of the code base is defining structs and constants related to adding support in tcpdump for different protocols. So if you wanted to add, if you wanted to modify tcpdump for your for a protocol you're inventing or whatever, it seems like as long as you have libpcap support for whatever it's doing, then you should be able to have a sense of like where you would modify tcpdump. You'd create some sort of header file that has a bunch of constants in it, and you'd change probably a relatively few call locations, because we didn't see many like call sites in the main C files where it was like looking at whether something was a Sun RPC or a or NFS or NTS or whatever. So presumably those decisions are made in a relatively small number of places, and you'd be able to modify it. So that's it for me. Tomorrow will be Theme Thursday, where we have like a carryover theme from previous weeks, and the theme right now has been Haskell build systems. If I remember correctly, I'm looking at Cabal, which is, I'm not sure if it's really a build system, but it's like the package manager for the Haskell environment. So if you're interested in Haskell or interested in just code in general, then hopefully I'll see you there. And thanks for watching. Bye.